Hello there and welcome to another video. Today we're going to see how to create our own Docker file to deploy or share our application in a Docker image that is exactly the same regardless of the environment where you use it. To create your Docker containers, first you need to know the application, how it is deployed and how it is executed. But you also need to know the dependencies required for your application to work. This will be more or less complex depending on the application you use. For this video, we will use, of course, Pandora FMS community version. Why Pandora FMS? Well, because it is an application I am familiar with, in addition to being a complex application. The purpose here is to not just make a video about creating an image with an static web in an HTML file with an NGINX server. But why community? Well, as you know, Pandora FMS has both community and enterprise versions. But of course, enterprise packages are only available for enterprise clients, whereas the community version is available together with its source code for everyone. So it's a perfect tool for this tutorial. Do not worry if you don't know what Pandora FMS is or how it works. We will make specific videos to explain all that. Here we will just learn to create Docker images from a Docker file. On the other hand, if you have clicked on this video looking for a Pandora FMS container to display your tests, but you don't want to create it yourself, go to the end of the video. There you will see how I execute the image directly from our public Docker Hub repository. You will find the exact time in the description. We will make another video focusing more on container execution and the use of Docker Compose, but this is a good place to start. To create a Pandora FMS image, we will actually create two different images. Pandora FMS needs many dependencies, and if everything is in the same image, it would take much longer to execute it. Also, dividing the creation process into two separate images will be easier to understand and learn. That said, let's get down to business. If you want to download the files we use in this video, you can just clone them or download them directly from our GitHub repository. There's a link in the description too. First, create the base image, starting from a CentOS 7 image. All Docker images start from another already built image. Even our application will start from this first base image. So start from a clean CentOS 7 image where you have to make some configurations and install the necessary packages. Let's take a look at this first Docker Compose file. As you can see, the first line is a commented line that is not taken into account when executing this file. It is simply a reminder of the docker build command for when you build the image. So we will start from the from line. As I said before, all Docker images start from another one that was previously built. In this case, we will start from the CentOS version 7 image. As you can see, we're using the colon character to separate the version. That is what Docker calls tag. Tags are usually used to identify the application version, but this will depend on who generates the image. We will see it when we generate the final image. Then we have several run statements. An run basically tells Docker to execute this command when building the image. In this case, we can see that we define a repository and install a series of packages, those dependencies I told you about before. Keep in mind that these containers are designed to run in the background, so we only have to install the minimum. The lighter and more efficient your container is, the better. That is why in installation statements, by using the yum handler, we are enabling the option so that it does not download or install any documentation, which takes up space. On the other hand, at the end of package installation, we finish with a yum clean all, so that it clears all the cache it's stored when installing. Finally, use the expose sentence where container accessible ports are defined. Here port 80 for HTTP, port 443 for HTTPS, and 41121 for Pandora FMS tentacle port, and port 162 UDP for SNMP trap reception. With this, we have our Docker file finished. Just execute the docker build command to create the image. At this point, it will start executing all the commands that we have defined as if it were a recipe. In my case, it is quite fast because I already had them in the cache, but it can take a bit of time depending on internet speed and machine power. One thing to keep in mind is that each run execution creates a container layer. So for instance, if we change only the last command, it would only affect the last layer, and you will be able to use the cache of previous layers. That is why it is advised to leave the commands that will vary more frequently at the end, so you will use the cache better. It has the base image, so we can continue with our Pandora FMS image. If we go to the Pandora community directory, we see that we have the Docker file and a folder called sources, which we will see later. If we open the Docker file, we see that it is a bit different from the previous one. Let's analyze it. First, as always, we start from a from. But for this image, we will start from the image that we generated previously, so as not to have to worry about dependencies. That is what the base image is responsible for, so we will use the from line to reference it. For my image, I will type in the name I assigned to my base image, and you will have to type in yours. If you declare the name of my image, Docker will try to connect to Docker Hub and will download mine since it is in a public repository. Then we see that we will use the env statements. This statement initializes the environment variables that we defined. When building the image, an advantage of environment variables is that we can override them at runtime. What does this mean? It means you can enter them as parameters when activating the container, so you may use them to change its performance. Then we see that we will use the env statements. This statement initializes the environment variables that we define. When building the image, an advantage of environment variables is that we can override them at runtime. What does this mean? Well, it means you can enter them as parameters when activating the container, so you may use them to change its performance. In our case, we will use them to define the connection to the MySQL database needed for Pandora FMS to store the necessary data. Here we can see that we define a variable for each element that we require: the host, the user, the password, the port, and the name of the database. Additionally, we have the sleep and retry parameters, which are used by the initialization script to know how many times you should try to connect to the database if it is not available, and the waiting time in seconds between each retry. Then we get the workdir command, which tells Docker that everything executed from now on, such as run commands, will be done from this directory. It is similar to going to that directory with a cd and executing the commands from there. The next sentence is a run, which we already know. This run specifically defines the time zone we want for our container. I will choose Madrid, but you can choose the time zone that you want. You can even create the host server's time zone, but we will learn that in coming videos, where we will talk about the execution of the docker run command and the use of Docker Compose. Then we can see a couple more run statements for downloading and installing Pandora FMS packages from our Docker Hub repository, and downloading and configuring the Phantom.js binary that is necessary for generating reports. These commands are intended for configuring and installing Pandora FMS rather than the Docker file, so for learning reasons it is enough to understand that the run statement execute is a command. We can also find the copy statement. With this statement, we tell Docker that it must copy the files that we specify from our computer to the image that it will generate. In this case, it will copy the sources folder and its content in the /tmp directory of the generated Docker image, so it will include those files in the package. Remember that you can download the sources directory and its contents from my GitHub repository. We can also see the expose statement that we know, where we will set the same ports as before: 80 HTTP, 443 HTTPS, 411.21 tentacle server, and 162 UDP for receiving SNMP traps. And finally, the CDM statement. This statement will execute what we declare. When activating the container, it will be the default start command of any container that is started from this image. For this specific case, I have written a script that self-provisions the database and configures it if necessary. You just have to point to an existing database server and have permissions to create and edit databases, or at least permissions on the declared database. This script saves us having to go through the web installation process every time we activate the container. With this, we have the Docker file ready to build the image. We just have to go to the directory where the Docker file and the sources folder are and execute the docker build t command and the name of the image label. For my image, I will use this name since it is the one that I have declared to the public Docker Hub repository and the version of the application I am deploying as a label. Since we have used Pandora FMS 740 packages, we will set 740 as a label. Please enter and it will be up to Docker to create the image. Remember that we have to have access to the internet to download the references packages. Press enter and it will be up to Docker to create the image. Remember that we have to have access to the internet to download the reference packages. Like before, it may take more or less time depending on the power of your machine and the speed of your internet connection. but it will still take much less since the whole dependency installation is already packaged in the base image we generated previously. So we can build our Pandora community image with all the different versions we need without having to rebuild the dependency-based image. This will save us a lot of time in the future. I had already executed this command before, so I used the cache and it was almost immediate. And there we have it. In the GitHub repository in this same directory, you will have a file like this where I indicate the docker run command to execute this image. You just have to define the port of your machine that you want to forward to your container, the address of your MySQL server, the database to which you point, and its credentials. I will type in those of my test server. Then execute, wait a few seconds, and go to the IP of your machine from a browser and to the port we defined. And there you have your Pandora FMS instance activated. If you find it difficult to understand the docker run command with all those parameters, or you don't have a database server to connect to, don't worry. The purpose of this video was for you to create your own Docker images based on Docker files. So stay tuned or subscribe to our channel where we will upload more Docker videos. The following will deal with the docker run command, the use of Docker Compose, and how to create a complete stack of Pandora FMS application without the need for external database servers in a few seconds and with a single command. With this, we conclude today's video. If you have any questions or suggestions, do not hesitate to put it in the comments below. See you next time. Bye!